Let's solve the equation 64n squared plus 104n plus 40 equals 0. Okay, so these are some large numbers. The first thing we should always check is if there's a common factor. Okay, do we have a common factor? 64, 104, 40, and technically 0, they're all divisible by 8. So I can factor out 8. Of course, factoring out means I'm dividing that number out and putting it on the outside of the parentheses. 64 divided by 8 is going to be 8. So we have 8n squared. 104 divided by 8 is 13. So that's going to be a 13n. And 40 divided by 8 is 5. And all that equals 0. Now, I see that I have something times something equals 0. Okay, the zero product property technically applies here, but it would be nonsense to say that 8 equals 0. Okay, so we actually will just ignore that for now. Another thing we could look at is if I wanted to just eliminate this factor altogether, this useless factor, I could go ahead and divide both sides by that factor. 8 divided by 8 will cancel out and leave me with 8n squared plus 13n plus 5. And that equals 0 divided by 8, which is 0. So notice our equation got much easier to deal with. Now we're still going to use the AC method to factor it the rest of the way, but I'm going to ignore all that stuff that came before because I like this problem a lot better. 8n squared plus 13n plus 5 equals 0. Okay, so the AC method says that I need to start off by multiplying 8 times 5. That will give me 40. I need to find two numbers that multiply together to give me 40. But if I add those same numbers together, they add up to 13. Remember, the goal here is to split 13n into two terms. I can bring down the 8n squared. I can bring down the plus 5 equals 0, but I still need to know what to split this term into. Okay, well, 8n squared plus 13n plus 5, I started off by multiplying 8 times 5 to get 40, so I'm actually going to just start there. 8 and 5. Those multiply together to be 40. They add together to be 13. So first try, I got the two numbers, positive 8n and positive 5n. Okay, so 8n squared plus 8n plus 5n plus 5 equals 0. Okay, so I'm just rewriting these four terms here. And I'm going to group together the first two terms and the last two terms. And I'm going to keep bringing down the equal 0. 8n squared plus 8n. The common factor shouldn't be too hard to spot. It's 8n. They're both divisible by 8. They both have an n, at least one n. Okay, if I divide this by 8n, 8s would cancel, n squared over n. One of those n's on top will cancel with the n on the bottom and leave me with just one n, or n. And then if I divided this one by 8n, 8n divided by 8n, anything divided by itself is 1. Okay, now 5 plus 5n. They both have a 5 in common, right? So I can factor out a 5. If I factor out a 5, that would leave me with n plus 1. Good. The two parentheses match. I know I'm doing things correctly. I have two terms. Okay, and they both are broken up into factors. You will see that n plus 1 is a common factor for both of those. So n plus 1 is my common factor. If I divided out n plus 1, I'd be left with 8n. If I divide out n plus 1 here, I'm left with 5. So there we go. N plus 1 times 8n plus 5. We have factored the quadratic expression. Now, I'm going to take each part and set them equal to 0, as the zero product property says that I can. n plus 1, I'll subtract 1 from both sides to eliminate the constant term. All I'm left with on the left side is n, and 0 minus 1 is negative 1. On the right side, 8n plus 5 equals 0. I'll subtract 5 from both sides to eliminate the constant term 5. I'm left with 8n equals negative 5. I'll divide both sides by 8 to eliminate that factor on 8n. And so I'm left with n equals negative 5 over 8. Okay, so that's a bit of a longer problem, but we finally found our two solutions, negative 1 and negative 5/8.